gradient and intercept of line graphs, they have a lot of meaning in practical situations. And in this section, we're going to have a look at some of these practical applications. One of the things I want you to have a look at is this sentence, and I'll get you to write it down. A relationship that gives a straight line when graphed is a direct relationship. You can underline that word direct relationship. Between the two variables. Now what this sentence means is very simple, that when you've got one variable going this way, say on the x-axis, and one variable going this way on the y-axis, when you compare the two variables, when one goes up, so does the other one. And so we call this a direct relationship, and they go up at a steady rate. So the gradient is constant. So we're going to illustrate this in the following example. At the Athletics Carnival, Celine runs the 100 metres in 16 seconds. It says it is assumed that she runs at a constant rate. Now obviously that's not exactly right, because when a person takes off in the run, there'd be some sort of acceleration. So we'll have a look at this, but we will assume a constant relationship. So the first question is to sketch a straight line graph to model Celine's run. Now to do this, what we're going to do, and I'll write this down here, we're going to use 2 points. That's all we need to draw a straight line. Use 2 points to draw the graph. So one of the points is going to be the point 16 on the x-axis, and that was this part here, 16 seconds, and the distance 100 metres on the y-axis. The other point that we know is the starting point, which would be time of 0 when she hasn't started yet and hasn't travelled any distance yet. So when we put those together, we can get the straight line. So here's the first point up here at 16 seconds, 100 metres, and there's our starting point, 0, 0. So we'll take a line and we'll draw it. So let's see, I'll get an arrowed line, and we'll start in the corner here and draw it up like this, and we'll just take it right to that point there. So there's our gradient. Now the question B, or point number B, says to find the gradient. So in order to find the gradient, we need to draw in a triangle, a right-angled triangle. Now this has been done for you. There it is there. There's our 90-degree line in the corner. And what we've got here is a gradient. And remember, to get a gradient, we need a rise and we need a run. And in this case, the rise is 100. That would be 100 metres. And the run is 16. And if we use our calculator here, we get a gradient of 6.25. There's our gradient. And our units in this case for this whole thing is metres per second. And the last question here is to explain the meaning of the gradient. So what we can say here is that the gradient, first of all, the gradient of Celine's speed is in meters per second. So the gradient is the speed of Selene in meters per second. So that gives us a little bit of the meaning. And the other thing that we can write down is that her average speed, is 6.25 meters per second. So that gives an overall view of how we can use a straight line in a very practical situation. Now here's another graph of a situation that shows direct variation. In this case, the cost in dollars rises directly with the number of books. Now it simply means that each book would cost the same amount, because that's a straight line that's going up. So as the number of books increases at a constant rate, so does the cost in dollars go up in a constant rate, indicated by this straight line. So let's have a look at some of our answers here. It says, what's the cost of printing 500 books? All right, so what we need to do is to have a look at some points on the graph. So it says 500 books. So if we go from here and take it straight up to here and then go across this way. Now once again, these graphs are fairly hard for people to read. If they were more accurate on the scale, you could do it, but I'll write in the answers here. In this case, the cost of printing 500 books is $4,800. And you can read that off here, just below the 5,000 mark, $4,800. Now, if we read the other way, it said, how much would $3,000 buy in the way of books? So if I take the arrow again and go from 3,000 and take it across and then drop it down like this, we would come to the fact that you would have 280 books could be purchased for the $3,000. Right, so once again, not clear to see, but you can see that it's about that. That is the exact amount. C says find the gradient. In order to find the gradient, we need to draw in a triangle. Now I've drawn in a triangle here for you and put the numbers in to help. So the gradient in this particular example, and it wouldn't matter where you drew the triangle because it's a straight line, it doesn't change. So the gradient would be equal to a rise of 3,200, and that would be dollars, and that would be 400 books. And when you work this out, we get the number 8. So what does this mean? Well, the gradient, this point here, the gradient gives the units of cost. In other words, one book would be $8. So that's what it means. The gradient gives one book equal $8, and you can do that simply because it's a straight line, as I mentioned before. So the gradient is the cost of the book. So the gradient is the cost of one book. And then finally, it says find the y-intercept. What is the meaning? Well, you can see that the y-intercept doesn't cut right at 0. Simply means that if you look at it carefully, once again you can see it's greater than 500 and less than 1,000. So what we're going to say is that the y-intercept is approximately equal to 800. So that's $800. All right, so what does it mean? It means to print 0 books. So if you didn't print one book, to print no books at all, it would still cost you $800. So what are they? We would imagine these are setup costs. So these straight lines are used always in business and so on, very, very practical in order to measure units, especially the rates, costs, things like that.